Hello my dear students, welcome back. There are two questions that are left from this exercise 9.1. So today we will finish up the chapter. Just two questions left. So that we can move on to another chapter. So question number 15 of exercise 9.1. So this is a very interesting question and a very good question also. So let's see how we can solve this. Definitely solution is going to be easy, but it's all about our concept and practice, of course, definitely. So let's move into the question and without wasting much time. Exercise 9.1. A straight highway leads to the foot of a tower. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression of 30 degree, which is approaching the foot of the tower. That means the car is moving towards the foot of the tower at a uniform speed. This is going to be important for us. A uniform speed. 6 seconds later, after 6 seconds, the angle of depression of the car is found to be 60 degree. That means it has moved closer towards the tower. Find the time taken. Here we are not supposed to be finding out distance and all, it's about time. So let's see how we can do this question. Find the time taken by the car to reach the foot of the tower from this point. So I'm going to rub out the question now. Now you may have written down the question. So let's try to draw the figure. As I always mention, figure always holds the key. A straight highway leads to the foot of a tower. So let this be the straight highway and leading towards the foot of a tower. So let this be our tower. A man standing at the top of the tower, that is at the point A, observes a car at an angle of depression of 30 degrees. So from here, maybe he is observing a car somewhere around here whose angle of depression, line of sight is going to be this. Angle of depression is 30 degrees. So parallel lines. So this is parallel to the highway. 30 degree. Definitely this highway is considered to be a very straight road, not like most of the roads that we have here. It's not straight, it's bumpy, right? But definitely we are assuming very straight highway. Then, which is approaching the foot of the tower with a uniform speed. Okay, we'll keep that in mind. 6 seconds later, that is after 6 seconds, maybe after 6 seconds, he is at the point D. After 6 seconds, he observes the angle of depression to be 60 degree. He observes the angle of depression to be 60 degree. That is after 6 seconds, he observes the angle of depression to be 60 degree. Now the question is, find the time taken by the car to reach the foot of the tower. So from C to D, it takes the car 6 seconds. Now our question is, how much time will be now taken by the car which is moving at uniform speed to reach from D to B? This time we have to find out. Now going back to science, physics, what was the formula for speed? This concept we will be needing. Speed would be distance by time. So if we have to find out the time, then we will be using this formula, that is distance by speed. So this is the only way. There are some shortcuts, but now we are not going to use all those methods. We're going to see how it is exactly done. So time is equal to what? Distance by speed, because here we are emphasizing more on the board exams only. So the time is equal to what? Distance by speed. So we will be using this formula. So please, you can just maybe write it down somewhere in the rough book, because I'm going to rub this off now. So when we do use this formula, you will know what are we using, which formula we are using. Okay, all right. Now let's explain the question a little bit. That is, let AB be the tower. Let AB be the tower. Okay. Time taken to move, to cover distance CD is 6 seconds. Alright, so we are supposed to find out, okay, let me just be very specific, to find time taken to cover the distance, time taken to cover the distance dB. So we will just write down the formula also. So time taken will be distance, so that we will know now what to find out. Distance, that's going to be dB divided by speed, and this speed will be, actually I'm just writing it in bracket here for our own understanding. This is going to be what? Uniform speed. Okay. Alright, now so that means our job is to find out the distance dB. We may not be having very accurate not numerical values like other questions, but definitely don't worry, it's a very interesting question. So distance dB we have to find out. We also have to find out the speed. From where are we going to find out the speed? Even though it's mentioned uniform speed, definitely, because most definitely we will be finding out the speed, uniform speed, from the distance that is covered CD, which took us 6 seconds to cover. So from there maybe we can find out an equation for speed, and that speed we can use because it's uniform speed. So speed of the car from C to D will be also same as the speed of the car from D to B, because the speed is uniform. Okay. Now let's try to solve some the triangles, and maybe if we can find out the distance CD, if we can have some equation. In triangle, I'm not explaining the angle of depression in the question here because already mentioned, figure is also very well done, so I think that should be more than enough. In triangle, let's take the smaller triangle ADB. Let's see what we have. After that, definitely we will simplify. Let's say ABC, we'll go to that later on. Triangle ABC, tan of 30 degree is going to be AB by BC. AB by, nothing, we start with the smaller triangle, okay? ABD, tan of 60 degree, because for smaller, let's go to the bigger, otherwise it may not look very appropriate. We will of course get the solution, but what I mean is, let's go through the proper way. So tan 60 is root of 3, that is AB by BD. So if you cross multiply, BD root of 3 is going to be AB. Let's keep it as it is. Move to the next triangle. What is our priority here? We are actually trying to find out CD. Okay? Because if you can find out the distance CD, we can find out the speed, because time is given 6 seconds. So distance by speed. That speed we can use to find out our time. Let's see how it is done. So our priority here as of now is to find out CD. In triangle ABD, tan of 30 degree will be again AB by BC. Tan 30 is 1 upon root 3. By AB we can use this equation, that is BD root of 3. BC can be written as BD plus CD using equation 1. Okay, I'll rub this off for the moment now. Then if we cross multiply BD root 3 into root 3, cross multiply, is equal to BD plus CD. So this is root 3 to root 3, that's going to be 3BD. I'll bring this 1BD to this side, is equal to CD. So twice of BD is going to be equal to CD. That means B, okay, that's what we need. So let's keep that as our equation 2. So time, not time, speed. Speed of car to travel from C to D will be equal to what? Speed of the car to travel from C to D will be distance CD upon time. So what is the distance CD? We can also use twice of BD. What is the time here? 6. I'll not write on the units here for now. 6 seconds. Okay, 2, 2, 3. So this is the speed, general speed of the car, which we are going to be assuming. Meters per second, maybe kilometers per second. Unit is not mentioned, so let's just ignore that. So this is the distance traveled by speed of the car, normal speed of the car to travel from C to D. But we know that the speed is uniform. That means the speed taken by the car to travel from D to B is also going to be that same speed. What is our speed here? It is BD by 3, maybe meters per second or kilometers per second. That we have no idea about. Only the time unit we know it's second, but ignore that, no problem. So this is our speed. Now, what I meant was, so, look here, it's very interesting. Time taken by car to travel from D to B. So what will be the time taken by the car to travel from D to B? It's going to be distance dB upon speed. dB upon speed, right? You can check that formula. Time equal to distance by speed. So now what will be the time taken? Time taken will be dB upon, also, okay, no problem, dB, or we can write even, yeah, dB will be much better, or BD, it's all the same. dB upon speed. What is our speed here? BD upon 3. We can write down the reason here, since speed is uniform. So we can use this equation of the speed. So now dB into BD upon 3 will be, by reversing, 3 upon BD. Right, 3 upon BD. So dB, BD can be cancelled because we're talking of distance only. So your direction will not be a concern. But of course, if you wish, maybe you can even change this also. No problem with this, okay? Because we're not doing vector quantities here. dB also not a big problem there if you're confused. Because dB or BD, the distance is same, okay? From D to B, from B to D, the distance is same. Displacement is a whole new term, but we're not talking about displacement here. It's only the distance here. So dB we can cancel. So unit will be in terms of time, that's 3 seconds. That means the time taken by the car to travel from D to B is how much? 3 seconds. Alright, now all this happens in this question because of one specific reason, that is the speed here is uniform. If this condition that the speed is uniform is not given, then we'll have to find out other ways to solve this, or maybe not very simple to solve also if the speed was not uniform. Alright, so what was the key to this particular question? It was about the formula, basic formula, that is distance is equal to speed is equal to distance by time, so that, or time is equal to distance by speed. So we find out the distance, we find out the speed with the help of the time, and then of course we use that equation of the speed, because since the speed is uniform, with the help of that we just get the time taken by the car to travel from one point to another point. Alright, so you can please practice this question once again. It is a very simple question. Let's move to the last question. Let me not write down the question here, but let's read that question together. I hope you have your textbook there. The angles of elevation of the top of a tower from 2 points at a distance of 4 meter and 9 meter from the base of the tower and the same straight line with it are complementary. What concept are we going to use here? Complementary means what? When are two angles said to be complementary? Two angles are said to be complementary when the sum of the two angles will be how much? 90 degree. That means let's say angle 1 and angle 2. So if angle 1 is theta, then how do we find out angle 2? Then the other angle will be 90 degree minus theta. So that means if two angles are complementary, if I say that the two angles are complementary, so if I say that one of the angle is 30 degree, okay, two angles are complementary, alright, that means their sum will be 90 degrees. So if one of the angle is 30, what will be the other angle? It's going to be automatically 60 degree. That means 90 minus 30, that will be 60 degrees. So this concept of complementary angles will be required here. The angles of elevation of the top of a tower from 2 points. The angles of elevation of the top of a tower from 2 points, from the point A and from the point B. Let this be the tower. Let CD be the tower. So the angle of elevation of the top of the tower from the 2 points at a distance of 4 meter and 9 meter from the base of the tower. From the base of the tower, one is 4 meter and the other one is 9 meter. Definitely the one which is more farther away is going to be how much? 9 meter. That means let CD be the tower and we can explain, and the 2 points be B and A such that CB is 4 meter because it's from the base and CA is 9 meter. Let's keep track of the direction also, because these things are also sometimes important for us. So alright, it is given that in that case and in the same straight line with it are complementary. That means these two angles of elevation are complementary to each other. So but how much is it? It is not given. So we will have to assume, let this be theta. Let angle A be theta. Since angle A and angle B are complementary. So what will happen? Angle A plus angle B will be how much? 90 degree. What is angle A that we have assumed? Theta. Plus angle B will be how much? 90 degrees. So what will be angle B? Angle B will be how much? 90 minus theta, as I just discussed earlier. So this angle is 90 minus theta degree. How much? Exactly numerical figure we cannot say because these are just general assumptions. So it's going to be 90 minus theta. Alright. Okay, now what are we supposed to prove? We are supposed to prove that the height of the tower, is how much? The height of the tower is 6 meter. I hope you have written it down. I'll rub it off now. Okay. To prove height of the tower is 6 meter. Okay, let's go for the solution. Let's go for in triangle, any one triangle. Okay, in triangle, let's say ACD. Tan theta is CD by AC. Tan theta is CD by, what is AC? AC is 9. Okay, beyond that we will not solve any further because nothing can be solved so far. So let us keep as it is. Because here we are trying to get the proof CD is equal to 6 meter. Let's try with the other triangle. In triangle BCD, again, tan of, what is the angle here? 90 minus theta, maybe 60, maybe 45, we do not know. But in general, the angle is 90 minus theta, whatever is left of theta. Will also be CD by BC, in triangle, this one, BCD. Now, the twist here, the key. In the previous chapter, we have studied from complementary angles of trigonometry that tan of 90 minus theta is how much? Cot theta, and that application we will use here in the previous chapter, that is in chapter 8, I think the last exercise. We study there about complementary angles, trigonometric ratios of complementary angles. There we study that tan of 90 minus theta gives us cot of theta. So that means tan of 90 minus theta can be written as cot of theta equal to CD by, what is BC? BC, it is 4. If you want to write down the unit, you can write down also, no problem. Alright, now there are many ways to solve after this, but I'll just continue with this. What is cot theta? Cot theta can be written as 1 upon tan theta, that will be equal to CD by 4 meter. No problem with that, I guess, because cot theta value is 1 by tan theta. That again we studied in the previous chapters about trigonometric ratios and their relationships. Now what I'll do is I'll take the reciprocal on both the sides. Reciprocal, right? Reversing both the sides. Reciprocal. So this becomes tan theta upon 1 is equal to CD upon 4 meter. That is equation 2. Now if we compare equation 1 and 2, from equation 1 we can see that, okay, no need to also, we can just continuously do also. Now from equation 1 what we can use is tan theta can be used as CD by 9 meter, and this is of course CD by 4 meter, same equation. This is using equation 1. Now, okay, if we cross multiply, if I take reciprocals, just very sorry for that, if I take reciprocal tan theta by 1, this will be not CD by 4, it will be 4 by CD. I made a small mistake there, 4 meter by CD. 4 meter by CD. Some of you may have wondered, oh, what the hell is this guy again doing? What is happening and all? I'm very sorry for that. Small careless mistakes happens to all of us. Now got it down, taking reciprocal on both sides. So tan theta by 1, 4 by CD. Now cross multiplying, I have here CD square is equal to 9 meter into 4 meter. So CD will be square root of 9 4s are 36 meter square. Now CD, we are talking of length. Length can never be negative. So of course you may have been told to write down plus or minus 6 meter, because square root of 36 is 6 meter. But normally when we use the square and all, we are you might have been told to use plus or minus. Here this is enough, plus 6 meter, because why? Because CD is a unit of length. Length is never negative. CD, length measurement, we never do it as negative value. This will always be positive. So here directly you can just write down 6 meters. So I think that was what we were supposed to prove. We were supposed to prove that CD was 6 meters. So that's it. That's our proved. So these questions are not difficult at all. If we just do it with a little bit of patience, it is always easy. But of course, don't forget to practice. So my dear students, this is where we wind up our chapter on chapter 9. So in the next video, definitely, if it is helpful for you, we will start off with another new chapter. That is most probably, let's see what we can start. Okay, so looking forward to the introduction of the next new chapter. Alright, so till then, study, stay safe, and of course, please don't forget to like, subscribe, and of course also share. So till then, bye bye, take care, thank you.